Is it the truth? Is it fair to all concerned? Will it build goodwill and better friendships? Will it be beneficial to all concerned?
Today, our program is Jerry Lochenauer is going to talk to us about emerging aerospace systems. And like Jim Miller said, this program came to us by one of our members suggesting it. Dave Eberly gave me Jerry's bio and said, I think this would be interesting, and we said it certainly would be. And so please welcome Jerry Lochenauer to talk to us.
Thank you. I'm coming to you from 40 years in Southern California. I moved here to the Lancaster area, and I did learn how to say it right off the bat 2 years ago. So I'm new to your area, but I appreciate the opportunity to talk to you. I did have a good excuse for not knowing how to pronounce Lancaster, though, because when I first moved to California, I lived in Lancaster, California. And that's where the NASA Flight Research Center is. So that was my first exposure to Lancaster. Okay. So a little bit about aerospace systems. These are the things I'm going to talk to you about. A little history mixed in with where's all this going. So main focus is on the emerging technology and where that's going to take us in the foreseeable future. What we tend to do with any new technology is we tend to overpredict what it will do in the near term, and we underpredict how it will change the long-term future. So some of these things, you may not see them tomorrow, you may not see them in 5 years, but in 10 years, 20 years, you can bet that these things are going to change the world. Okay, so we're going to talk about high-speed flight. We're going to talk about airships, all those other things that you saw on the list there. And one of the big things is electric flight. So you're seeing electric cars now. I don't know if any of you have hybrids or Teslas or things of that sort. We're going to see that same trend in aerospace systems. So to start out with high-speed flight, 1947. So I think that's 71 years ago, if I can do the math, right? 71 years ago, we went supersonic for the first time. A fellow by the name of Chuck Yeager, right, flew that airplane, the X-1, and went beyond the speed of sound. And roughly speaking, that's 761 miles an hour. That's at standard atmospheric conditions at sea level. You can get other numbers depending on the atmospheric pressure and the temperature and so on, but roughly 761 miles an hour. And that's the airplane he flew. It was rocket propelled. So it was a rocket motor in there that took him to that flight condition. Then in 1967, we went Mach 6.72 in that vehicle that you see there, the X-15, went almost Mach 7. Again, rocket propelled. So rockets are good for going up into space, one-shot deals. You know, we have SpaceX now that's starting to come up with reusable rockets. So we actually bring back the first stage and reuse it. It's not something you can turn around just by pumping in gas and go again. It takes quite a bit of refurbishment to get those rockets ready to go a second time. So it's really not a practical way to fly in terms of commercial or general aviation or anything of that sort. They built 3 of these airplanes, just test articles, flew them for about 10 years, and really very productive program, flew about 200 flights. Then in 2004, we're still upping the Mach number. So here we're up to almost Mach 10, 9.65 Mach number. So almost 10 times the speed of sound. That's a little over 7,000 miles an hour. And if we had a vehicle, a biz jet or a commercial airplane that could fly at those speeds today, you could get from LA to Sydney, Australia in 1 hour. Okay? So real advantage to doing that. And that last vehicle was not rocket propelled. This is a scramjet propulsion. So this is a much more reusable, you can fuel it up and go again. So that was the main challenge in getting, these high-speed flight conditions, was getting the propulsion down. We had the Concorde, right? We could go supersonic a few years ago, commercial. Quit flying in 2003, not practical. So they're still working on trying to get both biz jets and commercial jets to go at greater than Mach 1. The Concorde was Mach 2. One of the challenges of going supersonic is you're not allowed to go supersonic over land. So one of the things that held the Concorde back, it could only fly over the ocean at supersonic speeds. We have restrictions in almost all the major countries where, because of the sonic boom, you're not allowed to fly supersonic over land. So one of the things that has been going on recently is trying to figure out how to shape the airplane so that you reduce the sonic boom. How many people here have ever heard of sonic boom? Okay, so you know what that's like. It's a thump thump, and if you're in your house, it rattles the dishes and that sort of thing. When I lived in Lancaster, California, it was right next to Edwards Air Force Base, and you used to get that quite often, either at work or even sometimes in the local community. So here's an airplane, the X-59. So we've gone from X1 to X-15 to X-59 and all the X's in between. So all these are experimental, sort of one-of-a-kind airplanes where they're trying to prove certain things, you know, in flight. All right, now we're going to go to the other extreme, airships. Okay, not very fast. We had a lot of those back in the 20s and 30s. We're called blimps or other terms that were used for those vehicles. We still have a few flying around, the Goodyear blimp that will show up at football games and things of that sort. They really had their downfall in the 1930s. There was a series of crashes where airships crashed, both in Europe and in the US. The most noteworthy one was the Hindenburg in 1937, a big fiery explosion. So they were using hydrogen in some of the vehicles at that time, an explosive burning gas. Helium is the most forgiving gas. That's what they're using today. So that was the 30s, but this is a Lockheed Martin so-called hybrid airship. So this vehicle it takes off. You have to have a ground roll with that airplane, that vehicle, that blimp, to take off. So it's half buoyant lift and half aerodynamic lift. So you do have to get some forward speed for that to become airborne. Lockheed is experimenting with that as we speak, relatively recent. And there's this thing being built by Igor Pasternak, a guy from the Ukraine that came over to the US and out in California is building this airship, which is a variable buoyancy airship. So it has compressors on board, so you can take the helium and you can either release it into the airship and become buoyant, or you can compress it down, reduce the amount of helium in the volume, and descend. So it's a variable buoyancy system. This thing, as you can see, is quite large. You can see the people down here. This thing is about the size of a football field. This is their first prototype. They have them on the drawing boards that are over 900 feet long, so 3 football fields, with a 1 million pound payload. And the market, they think, for these is to carry payloads into remote areas. So if you're going to build a wind farm for wind-generated energy in the tundra of Alaska or Canada, there are no roads, there's no way to get there. So you either pay the expense of building a transportation system to the site, or maybe you'd use something like this to carry the payload in and lower it right there on the spot. With the variable buoyancy, one of the problems you have with airships is as you offload payload, they want to go up, right? So with this thing, as you offload payload, you compress the helium and you keep your buoyancy fixed, and you can stay there on the ground and offload all of your payload. So pretty clever idea. It's still in development. It is in flight test in Montebello, California. All right, next generation commercial transports. There's work going on at MIT, Massachusetts Institute, and NASA looking at ways of reducing the noise. So embedding the engines on the top of the airplane and shielding them from below so that the noise from the engine does not propagate to the ground. That's one of the big things. And then putting them on the back where they can flow some of the air over the fuselage, sort of increasing the lift and reducing the drag of the airplane. You want to go to higher aspect ratio wings, which is like a glider, right? You want a lot of wingspan for the given area, and you can get more efficient flight that way. And so they may go to braced wings like we used to have back in the old days with airplanes, and doing that again to get a more efficient flight. And then Lockheed is looking at what they call a box wing. So actually tying the main wing with vertical tails, if you will, joining the main wing with the horizontal tail and making it a box configuration. Also, Boeing, this is a blended wing body. This is a small subscale remotely piloted vehicle being tested at Edwards Air Force Base. And you can see the dry lake bed there. So one of the reasons Edwards is where it is because you can land a experimental aircraft, not necessarily on the runway, but in these huge dry lake beds, and they're just like a concrete highway or runway. All right, and then air traffic management. One of the things going on there for some time now, we've had 3D air traffic management, where they control where you are in space, right? X, Y, and Z. Altitude and position in space. Now they're going to the time dimension as well. So 4D navigation, so they will control the spacing of all the vehicles. So in the paths that they fly in the sky, they would all be spaced in such a way that when they get to their terminal airport, they're at the right spacing to land, boom, 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 take off same way, and have all that be much more efficient as we get denser air traffic. Okay, electric propulsion, I said that was a coming thing. I call it here Prius or Tesla in the sky. So it's using that same kind of concept. This is an all-electric vehicle, an X57, that is being built as we speak out in Scale Composites in California and will be tested at the NASA Flight Research Center. It has distributed propulsion. So one of the things with electric motors, it's easy to put multiple power devices, multiple propulsion, multiple lift generators, distributed across the airplane. So you not only get thrust out of those motors, you can also improve the lift on the wing by using those motors to increase the airflow over the wing. So that's what this vehicle is focused on. They have already been testing this concept on a semi-truck, would you believe, out on the dry lake bed at Edwards, putting a wing like this up on a semi-truck and going 100 miles an hour across the dry lake bed. And also Uber, they're testing autonomous cars, as you know, in Pittsburgh. They still have a driver in them, but they're autonomous and being tested. They're also looking at electric-powered small vehicles to be used in the city to take people when you fly into the major city airport and you need to go downtown, not to get in a taxi cab or an Uber car, but to get in one of these Uber flying machines, take off vertically, fly into the inner city somewhere, and set this thing down vertically. So again, electric powered, lots of different distributed propulsion, tiltable, so you can tilt that wing, take off vertically, tilt it forward, fly at high speed, tilt it again and land vertically. And Uber is planning to do this currently in Los Angeles and Dallas as their first test cases. They're currently looking for a third international city in which to run these tests. This is what I would call more the hybrid propulsion. So it's like your Prius or your Camry hybrid, where you've got a gasoline-driven engine and an electric motor. Well, here you've got a gas turbine, but it's not putting out thrust. It's driving a generator, which is then stored here in a big storage battery and then distributed out to these electric fans on the wing. So these don't burn gas, they're driven by electric motors, and they provide the thrust and they increase the lift over the wing because they're sucking in air over the wing and increasing the lift on the inboard portion of the wing. So again, much more efficient flight they're looking forward to downstream. Airbus in Europe is building this little trainer aircraft. Again, electric powered. These are not jet fuel-driven fans, but electric fans. And their hope is here to be able to lower the cost of getting a private pilot license to a third of what it is today. So with not having to buy the fuel and not having to do all the overhauls and certifications that are required on reciprocating engines that drive up the cost of owning a general aviation airplane today, they hope to dramatically reduce the cost of getting a private license. Also, Cessna, the general aviation community, is working on similar concepts for their more conventional airplanes. And self-launching gliders. So how many people in here have flown a glider or have flown in a glider? Okay, just a few. And normally you get towed up, right? You hook your glider up to a tow airplane with power, and he tows you up, releases the rope, and you glide from there. And if you're lucky or you know what you're doing, you can soar and climb from that release condition. I have a friend in California again. He's about 83 years old now. He did have the world's record in a glider at 52,000 feet. He soared up to 52,000 feet. The record just got broke by his glider, someone else flying it, a new machine that he's designed. Just last summer, they broke the record at 54,000 feet. They are down in Patagonia as we speak in South America with that same glider trying to get to 90,000 feet. And their hope is that we've heard of the polar vortex here, right? In the winter, that polar vortex comes down over Canada and we get really cold weather here in Pennsylvania. Well, they have the same thing in the southern hemisphere, and it oscillates around. It's a very high altitude wind pattern up in the 70, 80,000, 90,000 foot range. And down in the southern hemisphere, about 4 times a year, that polar vortex will come up over the tip of the Andes Mountains. And so they're hoping to come off the Andes Mountains into this polar vortex and get up to 90,000 feet. So we'll see. That's a promise. They're not there yet. So, but a self-launching glider. So an electric motor again that can either be tilted up, as you see here, and used to launch your glider. So you take off from a conventional runway with no tow, power yourself up to your soaring altitude, fold the electric motor back, and glide. So that's one approach with a retractable electric motor. And then there are others where that motor is fixed to your vertical tail, and when you get ready to soar, you simply fold the blades back along that motor and again soar with your glider. This is a solar electric vehicle. You can see it's catapult launched by 3 human beings. So a very lightweight flying machine, but this is in the desert, I think in Yuma, Arizona, where they set an endurance record recently, back in 2010, with this flying machine. It's solar electric, so you can see the electric motors there. They do go around, so that is your propulsion. And they flew for 14 days with that flying machine. And as far as I know, they could have stayed up much, much longer. They just got tired of being in the desert, I guess, and decided to call it quits. They had made their point. We can fly these kind of machines for extremely long periods, night and day, right? So you collect enough power during the day from the solar energy, store it that you can persist overnight, and continue to fly the next day. Now, if you were in Pennsylvania and you had a lot of clouds, or maybe not so good, but in the desert that works fine. This is another vehicle. How many people heard of this? The Solar Impulse 2. Show of hands. Okay, a few. It's done a round the world flight now. Before it did the round the world, it came to the U.S. and flew coast to coast in the U.S. And it stopped several times. It doesn't go, extremely long periods. So you stop, take off again, stop and rest for a while, a day or two, and fly again. So they did a round the world flight. Took them over a year, so 16 and a half months to make the journey in 17 stages, so they stopped 17 times. They did have to cross the Pacific Ocean, as you can imagine. It flies at 47 miles per hour. Very slow for a flying machine. You can see solar panels across the whole top of the wing, across the top of the fuselage, across the horizontal tail. So lots of solar collectors there. And again, they would fly overnight at full power, climb up to their max altitude during the day when the sun was shining, power back to save energy during the night, and descend. And then when the sun, hopefully they're still above the water when the sun comes up the next morning, and climb back up again and continue their mission. And they were successful at doing that. They were in the air 23 plus days. And they were down for quite a period of time in Hawaii, redoing the batteries. So they learned some things in sort of the first half of their journey. They flew from Dubai to Dubai, and they did have to redo the batteries, and that took them several months at that point. Okay, and then vertical takeoff. I haven't said anything yet about helicopters or rotary wing vehicles. We've been building helicopters for a long time, and they're very, very good, very efficient at taking off vertically and landing vertically. They can't go very fast in forward flight. And the reason is because the big rotor going around, right? You get the forward flight added to the tip speed of the rotor as it advances, right? And when that gets to near sonic conditions, almost supersonic, the drag goes up horrendously. So you're limited by how fast you can go forward in a conventional helicopter. So one of the things that's being looked at is a bunch of little electric motors driving smaller rotors and getting your vertical lift, so the same efficiency in vertical flight, takeoff and landing, but the tip speed of these little rotors is not nearly as great as the tip speed on these very large rotors, a single rotor. So this is being done in Germany, a company called Volocopter, and that may be something you see in the future for rotary wing devices. Autonomous air vehicles. You've all seen the quadcopters. Probably you or your children own them. A lot of controversy in terms of where you can fly them, looking into your neighbor's backyard, etc. So they carry cameras, they carry all kinds of sensing devices, and the police forces are using them to catch bad guys, so that's a good thing. The military is using them in all sizes, from teeny tiny all the way up through like a 1 foot span to the much larger devices, the Predator and the Global Hawk. Global Hawk is almost a 737 size flying machine, so jet powered and quite large. There's a picture of the Global Hawk in flight and on the ground. Again, you can get a feel for the size of the airplane. A great big SATCOM antenna there in the forward portion that can get satellite communication, so you can fly this thing, control it, direct it, tell it where to go from the other side of the world. So in fact, when these things are flying in Afghanistan, most of the controllers are in Beale Air Force Base in California, controlling and telling the vehicle what to do in Afghanistan. And also, we've got unmanned autonomous vehicles being landed and taking off from aircraft carriers. Still experimental, not in production yet, but we've proven it can be done. And the Navy is out releasing procurements for those kind of flying machines for aircraft carriers. And I think to start with as a refueling aircraft, not as a operational military aircraft. All right, internet to the third world. We are at a stage today where almost half of the world's population, about 4 billion people, do not have internet coverage. Okay, they can't use internet on their smartphones and that sort of thing. So Google and others are out trying to get internet coverage to the rest of the world. Google is looking at two ways of doing that. This is one. It's built by, Google bought a company called Titan Aerospace, which builds a solar electric vehicle similar to those couple that I showed you a few charts back. And their goal for this vehicle is to stay aloft for 5 years. So the vehicle has internet connectivity on it, broadcast capability. You can make contact with that internet in the sky and have full internet coverage from having a few of these vehicles orbiting over your country, over your region. The other thing that they're looking at are hot air balloons, high altitude balloons. Sounds kind of strange, right? This thing can orbit. It can stay in one spot. It could hover above Lancaster, for that matter. Hot air balloons, what they're thinking about doing is having them just continuously circulate around the planet, steer them by changing altitude to catch the winds that will take you to the left, or winds that will higher altitude will take you to the right. So actually be able to guide it and position them over the country that they want to position them. And of course, then in a few weeks, they'll go away and blow around the world and come back in 6 months later or something like that. So which one of those concepts goes, I'm not sure. They're looking at both. And then roadable aircraft. I'm not sure that that's a critical need here in Lancaster, but the fellow that starts this company, he's got several hundred deposits down already for people to buy these vehicles. And he tells me that 80% of those people are not currently rated pilots. They are people that have had it up to here with their commute. Okay? So they work in a big city, Philly or New York or LA or Chicago, and they want to buy a house outside of town, which will be considerably cheaper than in town, buy a roadable aircraft, fly into town to drive to work, drive back to their local airport in the city, fly home to their local airport, drive home and park it in the garage. So you don't have to have a hangar at the office, you don't have to have a hangar at home, you can park it in your garage. So this all started with the Jetsons, right? You guys, some of you remember that, I guess, back in the 50s and 60s where this show was popular on television. And so now we've got this company outside of Boston, Terrafuga, that has built and flight tested this vehicle. You see it being parked in the garage here. You can drive it on the road. You can go to your airport and unfold the wings just with the push of a button. So it's very automated, very slick, and fly. And it's got a pusher prop, and you simply pull a lever in the cockpit or the driver's compartment, and it shifts the engine from the wheels to the propeller, and away you go. I've got, in some of these charts, I've added links so that if you want to go to the internet and look at these things in more detail, you can do that. And that's not the only one. There's a bunch of these being worked on around the world. In Slovakia, in California, a little three-wheeled motorcycle, so classified as far as the DOT is concerned as a motorcycle class vehicle. And again, put the wings on and fly from your local airport. These aren't made to take off from your driveway or the highway. You have to go to a legitimate little strip, airstrip to take off. In Germany, same thing. And then, would you believe, in 1949, there was in fact a flying car. And there were 5 of them, I believe, built. One of them I just saw a couple of years or so ago, sold, still flyable, sold for, I think, close to $1 million. But it was not nearly as user-friendly as the other one I just showed you, the modern one, right? This thing, it probably took you an hour to get it bolted together and ready to fly. And you towed the wings and the tails and so forth behind the vehicle on separate wheels and that sort of thing. Okay, and then subsonics, build your own microjet. This is a kit, so you can buy this and build it. I think there's only 5 or 6 flying. And Fran Hines and I went just a couple weeks ago up to Lock Haven, Pennsylvania. This was the site of the original Piper Cub factory. So it went out of business in the 50s or 60s due to a flood. And so their main plant for Piper now is down in Vero Beach, Florida. But they still have a museum, a Piper museum there. And they had a Sentimental Journey fly-in. And it was called Sentimental Journey to Cub Haven. So they didn't call it Lock Haven, they call it Cub Haven, right? So all these Piper Cub freaks, forgive me, and I say that lovingly, right? They all flew in there. It's a big fly-in. It was like a 5-day Woodstock event for Cub airplane nuts. And they had outdoor activities, singers, food available, all kinds of things, and hundreds of airplanes there of all different sorts, mostly Piper Cubs. But this is not a roadable aircraft. You can't drive this out on the road, but it would be big fun, I think. And we met a guy at this Piper Museum, at this event in Lock Haven, that had built one of these and flew it, and he gave a talk at this fly-in in Lock Haven. Okay, and then a couple little more crazy things. Jetman Rossi, this guy is from Switzerland. He straps this wing on his back, has a couple little jet motors that are actually built for RC airplanes, but with 4 of them and getting the biggest he could get, he's able to fly. He launches from a helicopter, so he takes himself aloft in a helicopter, jumps up, starts the engines, jumps off, flies, can go up to almost 200 miles an hour, 186 miles an hour, I think, max speed, cruises at like 120. And of course, with a helmet, I'm thinking I've never stuck my head out of a car window going 100 or 120 miles an hour, but that would be interesting. So that's Jetman Rossi, and then there's a jetpack being designed and flight tested in New Zealand, and the intent here is to sell this to people, right? And this you could take off from your backyard. Maybe not in the inner city, but in out where most of you folks live, you could probably get away with operating these from your backyard. Piston engine driven, two fans, and controllable, as you can see there, by little joysticks and so on the arms. You strap this to your back, and you can't walk around with it, of course. You just, it sets there on its own support, and you strap yourself to it and power it up and take off. And I've seen videos of it flying. I've not actually been there, but it is being flight tested and successfully. Okay, so I was told to end in half an hour, and I think I just about did that.